short-run production function. The short-run production function is also known as the law of variable proportions. The law of variable proportions is one of the fundamental laws of economics. It is the generalized form of the law of diminishing marginal return. The law of variable proportions states that as we increase the quantity of one input which is combined with other fixed inputs, the marginal physical productivity of the variable input will eventually decline. In other words, an increase in some inputs in relation to other fixed inputs will cause the output to increase, but after a certain point, the output from the addition of inputs will become less. Assumptions of the law. The state of technology doesn't change. Only physical quantities of input and output are considered and not the economic profitability in monetary terms. The factors of production can be used in any proportion. If all factors are of fixed proportion, then increase in one factor will not result in any increase in output. There are some inputs whose quantity is kept fixed. This law does not apply to cases when all factors are proportionately varied. When all the factors are proportionately varied, laws of returns to scale are applicable here. Let us understand the law with the help of this table. As per the concept studied, with increase in inputs, the output will increase and after certain point will decrease. So here we see that with first 3 inputs marginal product increases. Let this be stage 1. As inputs further increases, we notice that the marginal product decreases and come to 0. This is stage 2. Further increase of inputs will give negative marginal product. This is stage 3. Now let us see the graphical representation of these data. Let x-axis be quantity of variable factor of input and y-axis be output. With 1 unit of input, total output is 20. Average output is 20 and marginal output is 20. With second unit of input, total output is 50. Average output is 25 and marginal output is 30. With third unit of input, total output is 90, average output is 30 and marginal output is 40. Similarly, if we plot all the points, the graph will be as shown on your screen. From the graph, we notice the relationship between total product, average product and marginal product. When average product rises as a result of an increase in the quantity of the variable input, marginal product is more than the average product. When average product reaches maximum, marginal product is equal to average product. In other words, marginal product curve cuts average product curve from above, that is, at its maximum. When average product falls, marginal product is lesser than average product. Now, let's understand the behavior of each of the curves. There are 3 distinct stages of the law of variable proportions which are shown in the above diagram. Stage 1. The law of increasing returns. Stage 2. The law of diminishing returns. Stage 3. The law of negative returns. Stage 1. The law of increasing returns. In this stage, total product increases at an increasing rate. The total product increases sharply up to point I, where the marginal product is also the maximum. This point is known as point of inflection. After point I, as the marginal product falls, the total product curve increases but at diminishing rate. However, the marginal product curve is positive. Stage 1 ends where the AP reaches the highest point. Note, during this stage, marginal product curves remains higher than the average product curve. The law of increasing returns operates because, in the beginning, the quantity of the fixed factors is more relative to the variable factors. As more and more variable factors are increased, the fixed factor which was earlier remaining unutilized is now utilized fully, and thus the production increases. Also, as the variable factors are increased, the efficiency of the variable factor itself increases as division of labor and specialization becomes possible. Stage 2. The law of diminishing returns. In this stage, the total product continues to rise but at a diminishing rate until it reaches its maximum point S, where the second stage ends. In this stage, both MP and AP curves are falling but are positive. At the end of this stage, MP becomes 0. It is to be noted that when MP is 0, TP is at its highest point, S. This point is called the saturation point. Note, this stage is known as the stage of diminishing returns as both the AP and MP curves continuously decline. The stage is also known as the optimum stage of production as the producers seek to produce in this range. It is seen in this stage that as more and more units of variable factors are added, the production declines instead of increasing. This is because a point is reached where the amount of variable factor is sufficient to ensure effective utilization of the fixed factor. Now, if more variable factors are added, MP and AP curves decline because the fixed factors become inadequate in relation to the quantity of the variable factor. Another reason for the operation of diminishing returns is the imperfect substitutability of factors for one another. Stage 3. The law of negative returns. In this stage, the total product declines. As a result, MP of the variable factor goes below the x-axis, that is, it is negative. Since the MP of the variable factor is negative, this stage is called the stage of negative returns. At this stage, the quantity of the variable factor is used too extensively in relation to the fixed factor. Hence, the output falls instantly.